mean, there's no x squared occurring here, there's no y squared occurring here, there's no z squared occurring here. All the terms are linear terms. Okay? So basically, a line is a one-dimensional linear object, and a plane is a two-dimensional linear object. Okay? So as long as in the future you see the equation is linear. As long as it's linear, it is either a line if it is one-dimensional, or it is a plane if it is a two-dimensional object. Okay? Keep this in mind. As long as there's no squares appearing, it should be a linear object. The other thing I want you to be able to tell is, as long as I have an equation writing in this form, it should be very quickly determine its normal line. You just need to rid of the coefficients for A, B, and C. Right? As long as you have a linear equation, get rid of the coefficients for x, y, and z, and that's exactly your normal line. Okay? So two directions I want you to go. Still, one direction is, if I have a point, I have a normal line, I should be able to quickly go and find a equation. And in the other direction, if I have the equation of a plane, I should be able to quickly tell a point and what the normal line is. Strictly speaking, it's the normal direction on that normal line. Okay? So I will give you a couple of examples. And let's practice how to find the equation for the normal, for the equation of the point. Okay? So let's begin from the easiest case. If I have a point P2 minus 1 and 3, I have a normal line which is given by minus 1, 2, and 3. How do I find the equation? So Chelsea fan. You're Chelsea fan, right?
Oh, yeah.
What is your name again?
Emmanuel.
Emmanuel. Okay. So how do I find the equation?
Negative 1.
Negative 1 times x minus
X minus 2
plus
plus
2
2
times
y
minus minus 1. Alright?
Yeah.
Yeah,
Plus
plus
1.
1. And plus 3 times z minus 3 equals 0. Okay? I will give you one very simple principle to see why this is two-dimensional object. Okay? In terms of the line, you have one three-variable theta variable. That's essentially why it is a one-dimensional object. Right? You only have this parameter t, which is theta. Here I have 1, 2, 3 variables governed by a equation. So only 2 can be free. Alright? If you fix x, if you fix y, z has to be given by this equation. So basically you have 1, 2 variables to freely change. Are with me? So this is actually a two-dimensional object. 3 variables, 1 equation. So it has to be a plane because this is linear. Okay? For this particular one, you can also simplify this as minus x plus 2 plus 2y plus 2 plus 3z minus 9 is equal to 0. You can do the following. You can combine the numbers and move them to the right side of the equation. You're getting a pretty easy equation as the equation of the plane. Okay? Are with me? So I'll give you one more example before the small quiz I have today. We discussed 2 points will determine a straight line. How many points do I need to determine a plane? You need a 1, 2, and 3. So, and this is a very popular problem. If I have 3 points, P, let's say Q is given by 1, 4, and 0, and R is given by 0, minus 1, and 5. I want to find the equation of the plane which contains all the 3 points. Again, no matter what conditions we have, point plus normal. We have already got a point, right? You can choose either one of the 3. How do I find the normal?
So I find
PQ
it.
and then
So a lot of you already have the idea. I have 1, 2, 3 points. Right? So I want to be quick, so I can some more time.
Find vectors
I have
PQ and
the
PR.
vectors on the plane. I have a vector, for instance, PQ, and then I can find the vector PR, similarly as what we did before, right? Just taking the difference between the points. And I know the normal, by definition, has to be orthogonal to all the vectors contained in this plane. So I'm going to do a cross product between these two vectors, right? That's why we begin by introducing the cross product deductor and everything. So I compute PQ as a vector. I compute PR as a vector. I do the cross product. I will name this guy as my normal. Okay? So this is the normal which is given, and I have point which is PQ or R, and then the equation will be given possibly. Okay, and we're done. I can give you more varieties of this kind of problems, but in the end, point plus normal. Okay, and for straight line, point plus direction. Okay, so before the quiz, I want to give you, first of all, this is just a small quiz. I want you to test yourself. Okay? And if you find this quiz to be challenging, that means you need to spend more time to review the vector calculus. If not, then you're good. That's all. This is not going to be